There's such a delicious irony when it comes to squares. The square is probably the first shape you ever learned about when you were a tiny kid, either that or a circle. And yet, it is one of the most complex things we have in geometry. There is so much going on in the square, and that is because a square contains all of the characteristics of parallelograms, rectangles, and rhombi. So it's really a marriage of all of those shapes, and I would encourage you to check out the videos. There's a video for each one of those three. I'll put the links of those in the comments, in the pinned comment here. So let's just go through and see all of the wonderful things that are going on in squares. So we know that opposite sides are going to be parallel because the square is a type of parallelogram. So we're going to mark all of that. And all of the opposite sides are also congruent, but because the square is also a rhombus, it's actually that all four sides are congruent, which is maybe the first thing you ever learned about a square. Not only are opposite angles congruent because the square is a type of parallelogram, but they are also all right angles because the square is a type of rectangle. So we have that going on as well. Now, the diagonals. The diagonals of a square do bisect each other, but they are also the same length. They are also congruent, making all four of these halves congruent, just like in the rectangle. But like in the rhombus, those diagonals are also parallel, or excuse me, perpendicular. Diagonals can't be parallel. They're perpendicular. So we've got that going on. Now, the diagonals are also angle bisectors up here in each corner. So each of these smaller angles are congruent as well. And because they are 90 degrees, that makes each half 45. That 45 measure is unique to squares, although the idea of them being angle bisectors comes from the rhombus. So I'm just putting 45 in each corner here. So there's a lot going on, and again, because of all of these unique traits and all of the traits that it gets from being a rectangle and a rhombus and a parallelogram, you can do some very specific problems, and you'll be asked in your geometry course or maybe on the SAT or ACT about angle measures and lengths going on in squares, and you'll need to know these facts in order to answer those questions with success. So let's dive in. Here we have a question where we're given a diagonal and you're going to be asked to find the length of one side of a square. Now, there's some things going on here. Obviously, this makes a triangle. It actually makes two triangles. But I want to go ahead and mark up some facts here. We know this is a right angle, so we're dealing with a right triangle. And not only are we dealing with a right triangle, we are dealing with an isosceles right triangle because those sides have to be congruent because this is a square. We also know that these right angles in each corner are being bisected by the diagonal, so that this is a 45-degree angle and this is a 45-degree angle. So what we have here in this triangle, right here. This is a 45, 45, 90 right triangle. Now, it may have been a while since you've done 45, 45, 90 triangles, special right triangles. But there's a unique relationship between the legs and the hypotenuse of this 45, 45, 90 right triangle. We'll do a quick review. Basically, the magic number for a 45, 45, 90 triangle is the square root of 2. Let me switch my pen tip there. The square root of 2. So that means that whether we have a leg and we want the hypotenuse, or if we have the hypotenuse and we want the leg, we're going to use the square root of 2. Now, whether we multiply or divide depends. Generally, if we have a smaller side and we want a bigger number, we're going to multiply. But that's not what's going on here. Here we have the hypotenuse, which we know has to be the biggest side of any triangle, and we want the leg. So we want a smaller value. So we're going to have to divide by the square root of 2. So let's do that. 18 divided by the square root of 2. Now, you were probably told that your answer to any problem, any division problem involving radicals, cannot have a square root in the denominator. So we need to rationalize the denominator. And the way we do that is by multiplying the top and the bottom by that square root. That fraction I just wrote is just a form of the number 1. 8/8, 4/4, 3/3. Any fraction that has the same number on top and on the bottom is just a form of the number 1. So we can multiply it by that without changing the value of this thing. So this up top, 18 square root of 2. I'm about to run out of space. Oops. Let's move over just a bit. 18 square root of 2, and the square root of 2 times the square root of 2 is the square root of 4, which is just 2. So we have 18 square root of 2 over 2, and then of course we can simplify the 18 and the 2 to get 9, and then we keep that square root of 2. So the legs, specifically any of the sides of the square, is 9 times the square root of 2. We all know that they're going to be the same thing. That one is, and then these guys over here are as well. So that's how we do. We did a whole lot there. We used the information that we had about the square to find an answer, a length, and we had to revive our understanding of special right triangles and multiplying and dividing by radicals in order to do so. Let's see another one. Oh, actually, this is the same problem, but I wanted to show you another way to do it. We can also do this, if special right triangles aren't your thing, we can use the Pythagorean theorem to, again, find one side of this right triangle. Now, you may be wondering, how can I use the Pythagorean theorem if I only know one side? Well, it's helpful because both of these sides are the same thing. We're gonna call them both x. So the Pythagorean theorem, a squared plus b squared equals c squared, where c has to be the denominator, in this case 18. So we're gonna go x squared plus x squared equals 18 squared. So that is 2x squared equals 18 squared. And, oops, excuse me. 18 times 18. 8 times 8 is 64. That's 144. 1 times 8 is 8. There we go. 4 to 324. And we'll divide both sides by 2. That's going to give us 162. Whoop! Those cancel. X squared. So x is going to be the square root of 162. Now, let's erase this over here to give us a little bit more space. There we go. Now, how can we simplify 162? Well, 162, that's going to be 662 is going to be 81 and 2. 81 is 9 times 9. There is a pair. So x is 9 times the square root of 2, which is what we got on the previous slide. So if you don't remember the special right triangle rules, or if you haven't had that yet, you can also solve this problem using the Pythagorean theorem. Now, just for fun, here, I'm going to give you this length here. Whoops, excuse me. I'm going to give you this length here. Come on now, there we go, as 6. And we're going to find every other length in this triangle. Well, we know because this is also a rectangle and also a rhombus, that all of these halves are also going to be 6. And we remember, of course, that we have a right angle there. And so over here, let's look at this right triangle. We can use our 45, 45, 90 triangle rule. Whoops, let's get rid of that. There we go. We can use our 45, 45, 90 triangle rule to get this side. So this is going to be 6. We're looking for the hypotenuse. So we're going to be multiplying this time by the square root of 2. So each side is going to be 6 times the square root of 2. 6 times the square root of 2, 6 times the square root of 2, 6 times the square root of 2. So that we started with very little information, but then because of what we know about squares, we were able to find the rest of the lengths in this square. So that's everything on squares that I've got for you today. Again, I encourage you to drop a note in the comments to let me know what other topics you'd like me to cover. Thank you. I hope you will consider giving me a follow. Plan on building this channel out quite a bit, and hopefully there will be some things in it that will be helpful for you. You're doing a great job. Keep up the hard work. Proud of you. Take care.